Answer, I had a doubt.
Yeah.
It's regarding the transmit buffer. So in general, in CAN, we used to have multiple messages. So how many transmit buffers we used to have? So if it is 100 messages,
Okay.
in that,
So if see the transmit shifting register that we have now that at the end of CAN controller, that is only one. Right. So let me show you. I think there will be a transceiver diagram. Right. This is what a transceiver. See, this is a TXD. This is RXD. So incoming physical signals actually CAN high and CAN low. In that only both TX and RX are connected. See, the TX is also coming to CAN high and CAN low. RX is also fetched from CAN high and CAN low. Now question is how they can do transmission and reception at the same time. No module in a CAN network will do transmission and reception at the same time. That we all know. Because if one transmit, others will listen. That is multi-master communication. If there is an exchange happens, if this is a master, it will use this circuitry. If this is a receiver, someone is transmitting, it will use this circuitry. Got it now? So your physical signal will come in here and is digitized. So it is going right, this TXT and RXD inside the microcontroller, right? To get this TXT and RXD, there will be only one buffer. Initially, once they get that packet, let's say it is receiving, this is receiving, it goes bit by bit, they shift and form a 64-bit, maximum 64-bit frame. One frame, it is a CAN frame right now. Once initially it will go and sit in a RX buffer only. Once the frame structure is end of frame is received, they will move that to receive queue. There will be a queue, maybe 8 in some CAN controller it's 8 queues, 8 level queue, like that they have. So it will put that in the bottom of the queue. After that, next message comes. They digitize it and complete frame is got. They receive the complete frame. They put that in above the queue. Like that, they arrange the incoming packets. But the digitization of that physical signal, no, up to this it is like a voltage pulse only. After the digitizations, it will be stored in the register, no. It as a one frame, one complete frame. That one complete frame is stored as in queues. There is a queue. In that queue, they arrange them one after another. Similar way, when he want to transmit something, initially he will arrange them in a transmit queue, one after another. From there, they will fetch one packet at a time, and then they will shift them into transmit shift register, which is actually a buffer. So it will shift them as a physical signal in CAN high and CAN low. So even it is 1,000 messages, the message transmitted will go through transmit shift register. It has to go that passage. It is a single register. Similar way, when it is in receive, when some message is received, they have to come and sit in the receive shift register. So the entire frame I am talking about, from start of frame to end of frame, in case of CAN. If it is in case of serial USART communication, 8-bit, 1 byte, one complete byte, one frame there. Right. Once that one frame is successfully received, they will arrange them in queue. So shift register wise, the digitizing mechanism or shifting mechanism that they used right now, after that they will store in a temporary register that will be a single one, single entity. Did I answer your question?
yes, I'm sorry. So we used to have the queues in middle. So I used
Yeah.
to have that dot. So if we have only one or two buffers, how it could handle multiple messages? That's it.
Okay. If we have, yeah, the queue is there. In between, there is a queue. In that queue, they will arrange the packets. Right. Your transmission or reception should not override that queue. They have some other mechanism that we will see that later. When we study about CAN controller, anyhow, we are going to study in detail about controller as well as the transceiver. In that section, we will discuss further. Right now.
Yeah, okay.
Right. So this is analog. Then we have PSPIF, parallel slave port read write interrupt flag. One means a read or write operation has taken place. Must be cleared in software means we have to clear them. No read or write has occurred. So let us say I told that I can interface a LCD with PIC microcontroller right now. I told her on that day right now. So there are different ways to interface LCD display with a controller. One among them is parallel slave port. That means parallelly whatever that I want to display in that display, no, I will send that data in a parallel way, byte by byte, one byte at a time. As it is a parallel port, there will be an 8 pins will be there for 8 data. So this 8 data is going to 8 data pins of LCD. How we can judge one successful byte has been shifted to LCD? Let's say I am writing some hello in hello, I just shift H. If the H is completely shifted to LCD, PSPIF flag will be set to 1. So that after pushing a data to the PSPIF, after pushing a data to a slave parallel slave port, I can poll this particular bit whether the successful write operation happened or not. If I successfully transferred H, I will get this bit to 1. If there is a discrepancy, otherwise still it is shifting, still we are sending that bit, it is not received by the LCD, that bit, this bit will be still in 0 state. Make sense? This is to ensure that the bit that we transmitted from master to slave has been successfully completed. If it is completed, then this flag will be set to 1. So whether that slave is processing it, not processing it, that doesn't matter to us. Whether we shifted it properly or not. If that happened, immediately this particular bit will be set to 1. Parallel slave port interrupt flag. Analog to digital conversion, ADC interrupt flag, receive interrupt flag, transmit interrupt flag, SSP interrupt flag, CCP 1 interrupt flag, timer 2 interrupt flag. So if you look at this, all these are peripherals. Timer is a peripheral. Capture compare is a peripheral. Synchronous serial port is a peripheral. USART is a peripheral. Analog to digital converter is a peripheral. Parallel slave port is a peripheral. That's why they have given a name PIR1 register. Peripheral interrupt register 1, like that. Understood?
Yeah, answer.
Clear now?
Yeah,
Right. Then